Imagine a beam of light so powerful it could outshine the sun, if only for a fraction of a second. A beam so precise it could strike a mirror left on the moon, Apollo astronauts and measure the distance to our celestial neighbor down to the millimeter. This isn't the stuff of science fiction, it's the reality of modern laser science, where researchers push the boundaries of physics to unlock the secrets of the universe. Lasers, once confined to laboratories and sci-fi fantasies, have become indispensable tools in space exploration, astronomy, and even planetary defense. But what makes these beams of concentrated light so extraordinary? And how are they revolutionizing our understanding of the cosmos? At the cutting edge of laser technology sits the zettawatt equivalent ultra-short pulse laser system ZEUS, a marvel of engineering designed to recreate the most extreme conditions in the universe. By composing unimaginable amounts of energy into pulses lasting mere femtoseconds, a femtosecond is to a second what a second is to about 31 million years. This laser can simulate environments found near black holes or in the hearts of exploding stars. Scientists use ZEUS to study how matter behaves under such extreme pressures and temperatures, offering clues about cosmic phenomena we could never observe directly. These experiments could one day lead to breakthroughs in fusion energy, advanced propulsion systems for interstellar travel, or even new states of matter. But lasers don't just simulate the cosmos, they help us listen to it. The Laser Interferometer Gravitational Wave Observatory LIGO relies on the perfect stability of laser light to detect gravitational waves. The ripples in spacetime caused by cataclysmic events like colliding black holes. These waves stretch and compress space itself as they pass through Earth, but their effects are almost unimaginably tiny. LIGO's lasers, traveling through miles of vacuum-sealed tunnels, can detect distortions smaller than 1,000th the width of a proton. Without this precision, we might never have confirmed Einstein's century-old prediction, opening an entirely new field of astronomy, where we don't just see the universe, we feel its vibrations. Lasers are also transforming how we communicate across the vast emptiness of space. Traditional radio waves, while reliable, are painfully slow when dealing with interplanetary distances. A high-resolution image from Mars can take hours to transmit. Enter NASA's Laser Communications Relay Demonstration (LCRD), which uses infrared lasers to send data at rates up to 100 times faster than radio. This isn't just about speed, it's about capacity. Future missions to Europa or the outer solar system could stream high-definition video, vast datasets, and real-time telemetry with unprecedented clarity. Imagine astronauts on Mars video calling Earth with no lag, or a probe at Pluto sending back gigabytes of data in minutes rather than weeks. This is the promise of laser communications, and it's already being tested in orbit. Then there's the role lasers might play in protecting Earth. Asteroids have shaped our planet's history in dramatic ways, and while we're now capable of detecting potential threats years in advance, stopping them is another challenge. One proposed solution involves using high-powered lasers to gently nudge an asteroid off course. By focusing a concentrated beam on its surface, scientists could vaporize a small portion of the rock, creating a jet of gas that acts like a natural thruster. Projects like the Directed Energy System for Targeting of Asteroids and Exploration to Star explore this concept, suggesting that a network of space-based lasers might one day serve as a planetary defense system. It's a far cry from Hollywood's explosive solutions, but in reality, a slight adjustment over millions of miles is all it takes to turn a direct hit into a near miss. Beyond practical applications, lasers are helping answer some of the biggest questions in physics. The European Extreme Light Infrastructure ELI hosts some of the world's most powerful lasers, with beams so intense they can briefly generate conditions thought to exist only in the earliest moments of the Big Bang. By studying how light and matter interact at these energies, researchers hope to uncover new physics, perhaps even evidence of extra dimensions or dark matter particles. Similarly, experiments with ultra-precise lasers are testing whether the fundamental constants of nature, like the speed of light, have always been the same or if they've changed over the universe's lifetime. And let's not forget the role lasers play in basic space exploration. The Lunar Reconnaissance Orbiter has been mapping the Moon's surface with a laser altimeter, creating the most detailed topographic models ever made. Mars rovers use lasers to vaporize tiny bits of rock, analyzing the resulting plasma to determine their chemical composition. Even the search for extraterrestrial life has a laser component. Spectrometers aboard future missions could use laser-induced fluorescence to detect organic molecules on distant moons like Europa or Enceladus. From probing the fabric of spacetime to enabling real-time communication across the solar system, lasers are reshaping our relationship with the cosmos. They're not just tools, but extensions of human curiosity, allowing us to reach further, see deeper, and understand more than ever before. As technology advances, these beams of light will continue to illuminate the darkest corners of the universe, revealing secrets we haven't even begun to imagine. The era of laser-driven discovery is just beginning, and the possibilities are as boundless as space itself.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.